Hi, grade 9. Are you fine? Today we are going to uh, continue about learning about electrochemistry. Previously, we talked about how to build an electrochemical cell, and now we will continue about spontaneous redox reaction that takes place between the two compartments. A strip of zinc metal in a solution of Cu2 plus ion will react spontaneously without any catalyst. It takes out without any intervention. Uh, First, Cu2 plus ion gains two electrons to become Cu, and zinc metal, which is solid, loses two electrons in order to become an ion Zn2 plus and liberating two electrons. The first reaction is called reduction, and the other is oxidation. This is the overall reaction. Zn is oxidized and loses electrons to Cu. Although electrons are being transferred, electrical energy is not generated because the reacting substances are in the same container. Half reaction method for balancing redox reaction. The half reaction method divides a redox reaction into its oxidation and reduction half reactions. Steps in the half reaction method divide the skeleton reaction into two half reactions, each of which contains the oxidized and reduced from forms of one of the species. Balance the atoms and the charges in each half reaction. First, balance atoms other than oxygen and hydrogen, then oxygen, then hydrogen. A charge is balanced by adding electrons to the left side in the reduction half reaction and to the right side in the oxidation half reaction. If necessary, multiply one or both half reactions by an integer so that number of electrons gained in reduction equal to the number of electrons lost in oxidation. Add the balanced half reactions and include states of matter. Charges of electrodes. The anode produces electrons by oxidation of Zn. The anode is negative electrode in a voltaic cell or galvanic cell. Electrons flow through the external wire from the anode to the cathode, so that the direction of displacement of electrons is from the anode to cathode, where they are used to reduce Cu2 plus ions. The cathode is positive electrode in voltaic cell. Salt bridge. The salt bridge completes the electrical circuit and allows ions to flow through both half cells. As Zn is oxidized, at the anode, Zn2 plus ions are formed and enter the solution. Cu2 plus ions leaves solution to be reduced at the cathode. The salt bridge maintains electrical neutrality by allowing excess Zn2 plus ions to enter from the anode and excess negative ions to enter from the cathode. A salt bridge contains non-reacting cations and anions, often K plus and NO3 minus, dissolved in a gel. Flow of charge. Electrons flow the wire from anode to cathode, Zn to Cu, and cations move through the salt bridge from anode solution to the cathode solution. Anions move through the salt bridge from the cathode solution to the anode solution. By convention, a voltaic cell is shown with the anode on the left and the cathode on the right. Notation of galvanic cell. The components of each half cell are written in the same order as in their half reaction. The anode components are written on the left. The cathode components are written on the right. The single line shows phase boundary between components of the half cell. The double line shows the half cells are physically separated. If needed, concentrations of dissolved components are given in parentheses. If not stated, it is assumed that they are 1 mole. Um, Redox applied to the reaction of zinc with hydrogen ion. Look at the zinc having an oxidation number 0 and hydrogen having +1. Zinc here has +2, so that the oxidation number increases from 0 to +2, and the oxidation number here decreases from +1 to 0. The oxidation, one reactant loses electrons, reducing agent is oxidized. This is very important. Oxidation number increases. Zinc loses electrons. Zinc is a reducing agent and becomes oxidized. The oxidation number of Zn increases from 0 to +2. While in case of reduction, other reactant gains electrons. Oxidizing agent is reduced. Oxidation number decreases, so that hydrogen ion gains electrons. Hydrogen ion is the oxidizing agent and becomes reduced. The oxidation number of hydrogen decreases from +1 to 0. This is the end of our lesson. Thank you for watching and goodbye.